Hey, what's up everybody? It's Dan Pickett here at Launch Academy, and today I'm really excited to demystify the whole way in which the web works. It's so funny, you know, we talk to students all the time and really other people in the field and just in general, it's kind of fascinating that there are so many users of the web, but not everyone knows how the web works. So I'm going to read you in on sort of the mechanics of the World Wide Web and everything it has to offer in terms of the way in which it works and how it's used on a day-to-day basis. So we're going to get into the sort of the underpinnings of the World Wide Web and really demystify that term, the cloud, and whatever that actually means. So I'm excited to do this with you. And let's talk a little bit first about why this is so important to cover. Well, one thing that we want to do as front-end web developers, and really just web developers in general, is we always want to mirror our production environment with our local web development environment. So far in this course, in the HTML show, we have been working on the local file system, and we haven't been working through the context of a local web server. And before we can install and configure a local web server so that you can work on a web project like you would see it in production, we first need to understand some of those mechanics and some of those nuances before we dive in. So it's really, really important that we try to mirror our development environment with our production environment. And in order to really understand what a typical production environment looks like, we first need to kind of demystify all the crazy terms that's thrown around as it pertains to the underpinnings of the World Wide Web. So let's jump in, and today's session will be a little less sort of hands-on and code-oriented. This is actually going to be sort of more of a facilitation, sort of explanation. I'm actually going to use slides for the first time in the course, so just bear with me and try to follow along with the concepts. And as always, if you have any questions, we'll be listening on the Slack chat and also in the Facebook Live commentary. Awesome. All right. So we're going to dive in and we're going to define the mechanics of the cloud, as I discussed. And then we're going to talk about this idea of the TCP/IP protocols and how that really runs the web. Then we're going to take a look at servers and ports and how servers use ports to communicate with clients. And then we're going to demonstrate the protocols at work when you navigate to a web page. There's a lot of stuff that's actually happening when you navigate to sites like google.com, and we're going to kind of dissect each of those layers so you have a firm understanding of all the protocols and sort of network things that are happening in the underpinnings of your browser and the server that it's talking to. Cool. So what is the cloud? I see it all the time on commercials nowadays, and tech companies love to just kind of throw around this term, the cloud, put it in the cloud, it's always in the cloud, right? Or my information is safe in the cloud. That's a questionable marketing tactic. But really, the cloud is just a network. It's just a big, giant network of computers. It's not unlike the wireless network that you likely have in your home or in your workplace. You have a bunch of computers that can communicate and talk to one another. And that's what the internet is. It's just a giant network. And essentially, internet providers provide you with a way on or access to that giant network. And essentially, they provide the communication mechanisms that allow us as users of the internet to connect to other computers and servers. And in this relationship, our machines are the client, indicated by sort of the skinny towers in this diagram. And the servers that we connect to, the sites like google.com or yahoo.com, you know, those are the servers. And the internet service provider are sort of the arrows that connect our client with the servers that exist out on the web. So basically, the internet is this system of servers that sit out on the web, and servers are really just a fancy word for computers. Servers will basically sit out on the web on an address, which we're going to talk about, and wait for clients to basically request resources for them, from them. So we get this idea of sort of this request-response model on this giant network that is the internet. And your mobile phone, if you have a smartphone, is a client on the World Wide Web, just the same as your tablet or desktop. Everything is given a sort of a access or an ability to talk to the computers that exist in the cloud or in the giant network. And this is the sort of underpinnings of the TCP/IP relationship that binds all of the computers out on the World Wide Web together. And essentially the way it works is a client, whether it be your local machine or your mobile phone, sends a request to a particular server. And that server, if it's listening and available out on the web and active on the network, it's going to basically say, oh, okay, Dan's mobile phone is requesting this resource. I'm going to respond with that resource. And that all happens through this TCP protocol, which is the way in which you transmit data over a large network. The other side of TCP/IP is IP. So essentially every computer that exists out on the World Wide Web has an IP address. Every computer on the internet has this, and it's not unlike the address of your home. It kind of gives some hints as to where you're located, who owns it. There's a lot of meta information that's kind of captured as part of this unique identifier for who you are on the web. And everyone that has access, if you're watching us live or you're connected and watching this on YouTube later, everyone is talking through a publicly facing IP address. And this is what an IP version 4 IP address looks like. And it's just a string of numbers that uniquely identifies the service here at Launch Academy. And this is what the World Wide Web sees us as when we're browsing the web and making requests. So there are two versions that are popular right now in terms of the Internet Protocol or IP address. And essentially what's happened is when the internet really became popular, we were fine with this IP version 4 because we had a large number of addresses available for all the nodes on the network. Well, with the proliferation of mobile devices and media devices and basically having all kinds of stuff that exists online, we had a need to expand the number of addresses that are available. So IP version 4 looks like this, where we've got a string of basically 4 sets of numbers. IP version 6 looks like this, which vastly expands the available addresses that we can use on the World Wide Web or the cloud. So you may notice something interesting here from some of our front-end work that we've been doing in the HTML show. Notice the hexadecimal digits in the version 6 protocol. So not only are these strings of numbers extremely longer, but we are also expanding the number of digits using hexadecimal code to basically create a really large pool of IP addresses. So every computer that exists out there on the web, particularly servers, are going to have this public IP address. And this is sort of the place at which on the internet that server resides. Now, I've been throwing around this term server. What does it actually mean to be a server? Well, when you think of services and sort of mainframes and things like that, you may think of this kind of cool room with all kinds of air conditioning and wires everywhere, right? Well, you know, what's typical in most organizations is this is what your server room actually looks like. And really a server is a fancy computer. And it can be your local machine, or it can be something that is more typically a little more beefy from a hardware standpoint because there are going to be heavier demands on that system to basically service requests. So your server will basically sit out there on that public IP address and essentially hang out and wait for requests to be issued from clients. So that server is going to listen for requests on what's called established ports. And ports are not unlike the lines at the RMV. There's a numeric system that basically says, okay, the server is going to listen on this channel and only this channel, and clients are going to make requests on this channel. Any other noise that happens on the internet, I'm not going to listen for. I'm only going to listen for requests and traffic on particular channels. So like we've seen in other areas of engineering, one thing that we love as developers is this idea of established convention or patterns. And there's sort of a ubiquitous and widely accepted set of patterns for what communication happens on what particular TCP/IP ports. So we assign each protocol to a kind of specific number so that each server that exists out on the web is able to listen on a particular channel. So here are some of the popular port conventions that we see out there on the web. For example, when we're sending email, all of that is happening through the port number or the channel 25. When we send DNS requests, which we're going to talk about later in the course, or later in today's episode, you see that on channel number 53, or protocol number 53. And the two most popular protocols and where you see most traffic on the World Wide Web is port 80 and port 443. That's where the request and response for HTML documents actually comes in. So we have this idea of IP addresses, which look like this or look like this. Most typically today, at the time of the recording, IPv4 is sort of the most pervasive and easy to understand. And then we have these sort of channels that servers and computers are listening on as part of that conversation. Well, if you notice in your browser, and if you notice in all of the internet work that you do, you don't ever see these numbers. These numbers are sort of not apparent to you. They're not visible out there on the web. And if you're a common user of the web, you probably don't even know that every server that's out there on the web listens on an IP address. And historically, we've learned through the telephone system that learning a string of digits is super hard to do, right? It's hard to remember a lot of those strings of numbers and what they actually result in when you go to them. So thankfully, as part of the whole World Wide Web, there's an additional service that's involved called the domain name system. In the domain name system, you can think of almost like the white pages for the web, right? So I go to google.com and the domain name system actually resolves that or tells the client that you're looking for a particular IP address. So the domain name system is used to translate a domain name to an IP address that's sitting out there on the web. And that's really at its core the simplest sort of perspective around the domain name system. So when you buy a domain name on things like GoDaddy or Enom or things like that, you purchase the availability to attach that name to a publicly facing IP address. And as part of that buying process, you kind of decide on what your top level domain is going to be. So we talk about top level domains in terms of the .coms and the .net and the .org kind of areas of the web. And essentially there are registrars that control all of the names that are rendered or resolved under those top level domains. And just like IPv4 versus IPv6, the universe of available domain names has quickly shrunk. So as the web has evolved, we've had to create additional top-level domains, things like .biz or some of the more recent ones like .club or .charity. There's all kinds of top-level domains that are now available that we can use to create unique domain names. But the whole idea here is it creates the ability for me as an end user to easily remember how to get to a specific resource. It's so much easier for me to go into my browser and type www.google.com than to recall that 173.194.36.51 number. That's just crazy, right? So the DNS system is the white pages of the web. So when you go and you register your domain name, basically you point that domain name to what's known as a name server. And that name server is basically going to be the authority on what domain name resource or host is going to point to what IP address. And for us, we really like the service DNS Simple or DN Simple for all of your DNS hosting needs. I'm signed into my account here, but DN Simple is just this wonderful package of service where you can point your domain names to it and manage all of the DNS very easily and user-friendly wise using DNS Simple. So I highly recommend this service, really great. And if you're interested in hacking around with DNS, there's this wonderful site and wonderful freely available tool called DNS Stuff. And I have it open here on the first page here. So one thing that we can do to determine the name servers for a particular domain is we can perform what's known as a whois lookup. So the whois lookup is basically going to give us all kinds of information about the registration of our domains. So you can see here that we registered launchacademy.com on enom, which is our favorite domain registered service. And we've pointed that name to the DNS Simple servers so that DNS Simple can manage the resolution between our host names and their IP addresses. So that's really how you kind of match memorable names to IP addresses out there on the web. Cool. Also on DNS Stuff, you can get more specific information around particular hosts. So if we say www.launchacademy.com, we can get all kinds of information around how the DNS system pulls up data on www.launchacademy.com. We're not going to wait for this to load, we're going to move on. But again, just wonderful tool to kind of tinker with and play with. Give it a shot. And even if you're interested, try to register a domain name and use DNS Simple to resolve your host names to IP addresses. Cool. All right, so we talked about DNS. So let's talk a little bit about the communication tool that we use for sending traffic. We use this diagram here, this request response model, to demonstrate the interaction between our mobile device and a web server. So essentially what we have here is a client piece of software in the form of a web browser is going to issue a request on that 80 channel to a web server that exists on a publicly facing IP address. That server is then going to look to see if it has the requested resource and send it back to the client as a form of a messaging or transmission that the browser is going to use to render the HTML and CSS that we've been learning about throughout the course and throughout the HTML show. So let's see this in action and see what this is actually doing when I go to google.com. So essentially what I did with google.com is I typed in www.google.com in the address bar, and internally my browser resolved that to a publicly facing IP address. Once that IP address was resolved, it then actually went and tried to retrieve the index resource, which is the very popular Google search form. That was sent to me in the form of a response, which my browser downloaded and rendered for me as the end user. So the browser is simply just a client that makes requests and downloads HTML documents. The server sits out there and listens on the port 80 or the channel 80 and basically just awaits clients to make requests of it. And there are very popular web server software. Apache is probably the most predominant, typically runs on the Linux operating system, and we install Apache on computers that exist and sit out on the World Wide Web and essentially listens on that port 80 for clients to access it and request resources from it. There's also another open source, sort of lighter weight version or kind of adaptation of Apache called Nginx. And Nginx is also open source and popularly used on the Linux operating system. If you're a Windows shop or you're doing a lot of development on Windows, you might use the Internet Information Services server, and we call that IIS for short. And just like we use Chrome as a client piece of software, we use Nginx, Apache, and IIS as server software to basically field client requests and send responses as a result. And that's how the entire World Wide Web works, is you have clients in the form of laptop computers and mobile devices that are making requests to HTTP servers, and those HTTP servers are replying with responses that include HTML documents, images, CSS, JavaScript, all that fun stuff. And that's the entirety of the World Wide Web. But one thing you should know about HTTP. By its nature, HTTP is not secure. So if I'm a malicious user or a hacker, and I joke here and I say lead hacksaw, which is kind of a joke around the development community, if you kind of have hacking skills, you might kind of refer to yourself as a lead hacksaw, though I don't know many hackers that do. But essentially, if you wanted to do bad things, you could kind of sit out on the giant network that is the World Wide Web and listen in on the chatter between clients and servers. And one thing that's particularly worrisome about port 80 is it's what's called an unsecured channel. So if I am a lead hacksaw or malicious user, I can kind of sit out on the network and listen in on the requests and responses that are happening between clients and servers and trying to kind of harvest confidential information. So when credit cards started to be transmitted over the World Wide Web, we needed a way to secure the transmission of HTTP requests and HTTP responses. So we do so now over the port 443. So we talk on a completely different channel, and that channel is encrypted. So if I'm a hacker or a malicious user, I can't listen in on the conversation. There's an agreed upon key that basically signs the requests and the responses and basically makes it look like in a completely different language, an indecipherable language, so that there is extreme difficulty for a hacker to kind of listen in on the conversation. So know that as a web developer and as a user of the web, it's really important not to transmit confidential information, things like credit cards or passwords, over on a not secure channel. So if you're sending things like passwords or credit card information over port 80, your information is at risk to this sort of man-in-the-middle attack. That's what this is called, man-in-the-middle attack. And essentially, you should only be transmitting that confidential information over a secure channel. And thankfully, browsers have gotten really good about giving us clues and hints about when we're talking over a secure socket layer. So you can see here that we've got this little safety lock. It's a little small on my resolution here next to my connection to Nginx. And I can click that lock and learn all about the nature of the encryption of my SSL connection. And Chrome Inspector pops up and gives us great information about that. Most traffic on the web right now, by default, is being transmitted over SSL. It's just there's so much password and secure information that's being transmitted that a lot of traffic just defaults to going over SSL. And this is the safest bet, but for the purposes of our work in the next episode, we're going to start to locally host our own websites over the non-secure port 80 channel, or we may change the port number, but the transmissions between the client and the server will be non-secure. Cool. All right, so let's go ahead and recap. I covered a lot of material here. So the cloud or the internet is really just this one giant network, and every computer that sits out there and exists on that one giant network has what's called a publicly facing IP address. And that IP address is not unlike the address of your home. It's a way of identifying a particular node on the network so that you can access it and benefit from its services. And we use the domain name system, or DNS for short, to essentially resolve memorable names to those IP addresses. So think of the DNS system like the white pages for the web. We know the name of something, and domain name system basically translates that information to an IP address. The other thing that you should know about the World Wide Web is that the majority of web traffic takes place over the HTTP client-server request response model. The client or the web browser will issue a request, and the listening web server will serve that request with a response. And if you've properly formed your request, the response comes in the form of an HTML web page that's rendered in the context of your local web browser. And another important thing to know and listen and pay attention to is that there are non-secure natured communication over the web, and that's just plain HTTP. And then there's communication that takes place over a secure socket layer, which basically encrypts the traffic between the client and the server so that confidential information is safe. That's really what I wanted to cover in today's episode. Join us next time and we'll get you configured and ready to go on your local machine. I'm really excited to practice like we play, so to speak, and configure your local dev environment so that you're actually hosting real web pages over the TCP/IP system. We'll see you next time. I hope to see you there and in the chat room. Thanks.